Okay, so here we are back in chapter 10.4, and this is going to be all about inscribed angles. Now, back in chapter 10.2, we learned about central angles, which go from the center. The vertex starts in the center of the circle and goes to the outside of the circle, and the measurement of the angle was always the same as the measurement of the arc that it intercepted. Now, with inscribed angles, guys, okay, inscribed angles a little bit different. Inscribed angles the vertex starts on the edge or the outside of the circle and then goes across the circle to intercept with an arc. So if you look at the picture down there below, you see that the vertex is on the edge of the circle there on the left, and then as it goes across, it intercepts that arc in the red on the right side of that circle. Okay, so this is a little bit different. Okay, now with theorem 10.7, we learned that inscribed angles, guys, are always half of their intercepted arc. So if we look down at that picture again, if the inscribed angle is 40, then its intercepted arc would become 80. Or vice versa, if the intercepted arc there in red, let's say they told you it was 120 degrees, then that would mean that the inscribed angle was only 60 degrees. Okay? So pretty simple stuff, pretty simple math here. Just you got to remember, it's always going to be half. So this is a definite shift from the central angle idea. Okay? So let's look at some examples of this. So we want to find the following measurements here. So for the measurement of angle T, well, if I find angle T right there and I follow it across, it opens up to arc RS, and since RS is 48 degrees, I just take half of that, and half of 48 is 24, so the measurement of angle T is 24 degrees. Now for arc TS, so for arc TS you're going to have to do a little bit of inferring here and understand that from T to R is 180 degrees because that's a diameter. So if I understand that T to R is 180 degrees, and I know that RS is 48 degrees, well then all I have to do to find the measurement of arc TS is go 180 minus 48, and that gives me 132 degrees. Okay? So for arc QT, alright, now I got to figure out what angle intersects arc QT to figure this out. So if I look at arc QT and I see that, okay, at endpoint Q and endpoint T, both of those chords go back to point R, and so I want to look at the measurement of angle R, and since the measurement of angle R is 50 degrees, that means that arc QT is 100 degrees. Okay, because remember, inscribed angles are always half of their arc, so we just double that. Okay, so that gives me an arc of 100 degrees. Now, for arc QR, all right, once again, you're going to have to infer a little bit and use that diameter to help you out. Okay, so we know that from T all the way clockwise over to R. So if I go from T through Q to R, I know that that's going to be 180 degrees because that's the diameter of the circle. And I just figured out that arc QT was 100 degrees. So if I just go 100 or a 180 minus 100 degrees, I get that arc QR is 80 degrees. All right. Now, the last little bit here would be that if to figure out the measurement of angle TSR. Now, for the measurement of TSR, what you need to do is we need to add in that last little bit of the angle. So watch, it's going to come in red, and so now I've created angle TSR. Now, angle TSR opens up to the diameter. So if the diameter is 180 degrees, that means that angle TSR must be half of that, which would make it 90 degrees right there. Okay? And we're going to learn another theorem that's going to help you, not have to go through and do that math that way, and there's a shortcut, but we'll get to that later. Okay? So, the next part of this. So we've got some theorems here. If two inscribed angles intercept the same arc, then those angles are congruent. Okay? Pretty simple stuff. If you have one arc on one part of the circle, or one angle on a part of a circle and intercepts an arc, and another angle starts in a different part of the circle but intercepts at the same spot, then those two angles will be congruent. 10.9 says a right triangle is inscribed in a circle if and only if the hypotenuse is the diameter of the circle. So remember on last slide I said that if you have a triangle within a circle and that one of the angles in that triangle opens up to the diameter, then it's a right triangle in there. And we'll talk about that here a little bit more. And then finally, theorem 10.10 says that quadrilaterals can be inscribed in a circle if and only if its opposite angles are supplementary. And so this one you're going to have to just see it to really make it have sense. But if basically it's pretty simple. If you see a square, a rectangle, or any type of quadrilateral within a circle, then the angles that are opposite one another have to add up to 180 degrees. So let's practice this a little bit. So the first one they want me to do down there is figure out the measurement of angle HGF. So if I look at HGF, well, that opens up to that 90-degree arc, so therefore angle HGF has to be 45. And now I want to figure out the measurement of GFH. So if I were to draw in that second segment to make GFH an angle, okay, that angle would open up to the diameter. And so since the measurement of GFH opens to the diameter, half the diameter is 90 degrees, so that makes angle GFH 90 degrees. And then finally arc FGH. So if I go from F all the way to G over to H, well, we know that G over to H is 180 degrees, and then arc GF has to be the remaining after I subtract HF, which is 90 degrees. That leaves me another 90 degrees, so GF must also be 90 degrees. So then that gives me 270 as the measurement of arc FGH. Just got to do a little bit of subtraction and manipulation there. All right. Now, let's look at that quadrilateral within the circle. Okay, so I have quadrilateral LMJK, and they want me to figure out what A is, they want me to figure out what B is, and then figure out the measurement of LKJ and the measurement of arc LMJ. So, we learned that opposite angles within a quadrilateral that's inscribed within a circle have to be supplementary. So both angle A's, okay, have to add up to 180. So all I have to do is go 2A plus 2A equals 180 degrees, and then do some subtraction. Okay, so 4A divide 180 by 4, and we get 45 degrees. Okay, so remember, just add those two angles up and then set them equal to 180 degrees and work backwards. Now for B, that would also mean then that angle K and angle M have to add up to 180 degrees. So 4B plus 2B is 6B. 6B equals 180. So therefore B would be 30. Okay, so B is 30 degrees. And now the measurement of LKJ. So LKJ is that big angle. That's the 4B angle. So I take 30, multiply it by 4, and I get 120. Okay. And then finally the measurement of arc LMJ. So arc LMJ is basically from the endpoints of LKJ. So if I follow LMJ around the outside going to the right, that's going to be double that 120 degrees because that's its inscribed angle, and so I get 240 degrees for the measurement of arc LMJ. Okay? Alright guys, so I really didn't like how I explained the last slide of this in the original video, so I went back and I decided to change it up a little bit. So here we are again, looking at this quadrilateral inscribed within the circle. Okay, and so what they want you to do is they want you to figure out some pieces here, but there was just some visual information that I wanted to add in to make this a little bit easier. But just keep in mind that if you have a quadrilateral inscribed inside a circle, that theorem says that opposite angles will be supplementary. And so as we look at this, we might need that, we may not. Let's just get through into this. So if you look at JK here, they want us to figure out the arc of JK. And so what you want to do here is just understand that it's 360 degrees around the whole circle. So if we know 110, 110 plus 130 is 240, and 240 plus 54 is 294. Okay, so if you have 294 degrees of the circle already used up, then all you got to do is go 360 minus 294, and that leaves you with 66 degrees for JK. Now, notice that I put that 66 degrees up there at the top because that's going to be important here at the end to help you kind of figure out some things here. So now they want you to figure out the measurement of angle K. So to figure out the measurement of angle K, what I want you to see here is that if you look at angle K, where is angle K's two endpoints? Well, angle K, the vertices is obviously at K, and then it extends out to J and extends out to L. Now if you look at that arc there, that arc goes from J all the way over to L. Okay, and if you look at that, it's 130 plus 154. Okay, 130 plus 154 is 184. And then all you have to do is cut that in half because it's an inscribed angle. So the arc is 184, but the angle will only be 92 because you got to cut it in half. All right, now we're going to use the same idea to figure out what A and B are. Okay, so to figure out what A is, all right, what you want to do is you want to look at, okay, so 3A is where angle L is. Okay, 3A is at angle L's vertices. So if I look at angle L and I expand it out and I look at, okay, L ends at K and M. Angle L ends at point K and point M. So if I follow that arc it goes across 54 and 66. So 54 plus 66 is 110. Now here's where you got to be careful. Okay, you don't want to go 110 equals, sorry, 120, excuse me, 120 equals, okay, 3a, because that's not correct. You got to cut that in half. Okay, so half of 120 is 60, and then you divide 60 by that 3, and that's how you get 20 degrees left over. Let me just say that again. 66 plus 54 is 120 degrees for that arc. You got to cut that in half and then set that equal to 3a, because the inscribed angle is half of its arc. Okay, and once you do that, you get 60 equals 3a divided by 3, and that's how you get the 20. Now we're going to do the same idea here for B. So if I look at B, 4B is right there in the vertices of angle M. So angle M extends out to points J and L, and if I follow that arc, it goes from J to K, which is 66, and then from K to L, which is another 110. So now I'm at 176. Now I'm going to cut that 176 in half. Okay, so half of 176 would be, let's see, half of 166 is 83. Okay, and then and then add 5 more to that, so 88. So half of it, so then I have 4b equals 88, and then divide 88 by 4, and I get 22. Okay, so once again, from J all the way to L on the arc, going clockwise here, okay, is 176. Half of 176 is 88, and then 88 divided by 4 is 22. All right, so now for this, to find x here. So you have an inscribed angle, which is, its equation is 8x plus 10, and then you have that arc out there, which is 12x plus 40. So remember that the inscribed angle is half of its arc. So if I just set up the equation as 8x plus 10 equals 1/2 of 12x plus 40, you can work this out. Now another way you could do this is to go 2 times 8x plus 10 equals 12x plus 40. It doesn't matter. They're equivalent expressions, okay? So, or equations. So all I got to do now is I'm going to take half of 12x plus 40, which gives me 6x plus 20, okay? And then now I just minus the 6x over and minus the 10 to the other side, so I get 2x equals 10, and then divide by 2, and x equals 5, okay? And so there.